welcome back. This is A-Level Computer Science 9618 paper 3, and now this is part 2 of chapter 1, data representation. So we discussed about pointers and enumerated. So now we will be moving on to composite data types, which include set, record, and class and object. So let's start with set. User-defined data types have boundaries placed according to the programming's need. So it depends on you which one you are going to. You can go through non-composite or you can go to composite. In non-composite, there's pointers. Pointers is used in C language, C++. Enumerated, it's not so much useful except if you want to list down a list of if you want to list down the number of constant and you want to give them the values, each of them. But in composite form, you can have, in record structure, you can have multiple data types in one single body. Okay, in a set, you all know what is a set diagram, Venn diagrams, intersection union. We can do this in code form as well. Class and objects, this is object oriented programming. This is OOP. We will discuss this in P4. We will do the programming in P4, but for now let's understand about the concept. So inside language, in set notation, in set, you have this is a pseudocode. Type set identifies equals to set of base type. So this would be the name, like f letter is equal to set of base type. You can have char, integer, string, but I have chosen char, set of char. Then you're going to declare variable, declare vowel identifier, and you can have, you're putting values, and you're going to give the as letter. You're declaring this is actually a user defined data type. This is user defined. You have created a user defined data type. So for now, you need to understand about the pseudocode, but when we will come to programming, we'll do this in P4. Okay, but for now this is P3, so you just need to understand the concept. So this is set. Okay, in OOP, object and classes. Class is, you can say, a blueprint of a building. You can say, whenever we try to build anything, we will always need a blueprint, right? We will always need a map, something that could help us to make a building. You want to make a building, right? You are making Dubai's longest building, but in order to make this building, you need to have something, right? A map or a blueprint to make this building, right? A structure. You need to know the structure of the building. So this is what class is. Okay, object are those real entities which are made from classes. For example, a class human. So I have created a class human, which consists of the things. It contains attributes, and it contains methods that it can do. It contains attributes like age, name, gender, address, or skin color. So it contains the data, what it contains, right? It contains, skin color, age, name, gender. These are attributes. Okay, methods, that what it can do, what it contains, and what it can do. What it can do, it can walk, it can talk, it can eat, and so on. So we have created a class, and now if you want to make an object, for example, human, class human, Jason is a man, is equals to new class human, new human. So we have created an object. This is an object. Jason, you can say Alex, Jason, Abdullah, Ali. These are objects which are created from the class human. Okay, human is a class, animal is a class, um, Toyota car is a class, or you can say, earth is a class, or bird is a class. So these are classes, and we make object from these classes. So this object oriented programming. Okay, so we discussed about set and OOP. Now let's come to record structure. It's been We already discussed about this in P1. We discussed about record, structured. The structure is known as the record. Okay, so record has been widely used in C language. and it can be used, it has been used in OOP, or you can say class and record are quite similar. We will come to that in P4 why are they similar, but for now let's say record is something that allows you to have multiple data types. For example, you have the record. First you can do this is pseudocode. You have the name of a record type, t employee record, and you have these data types. You have these variables which have different data types like string, date, currency, integer, char. You can have so many multiple types of variables having multiple different types of data types, okay, inside a record. So these are variables having different um, defined data types, okay, built in. So record is basically having a combination of different built-in data types, or you can also have user-defined data type as well. Okay, so for example, I have created this declared employee1 as t employee record, and if I wanted to access any one of these variables, these are variables which are declared by different built-in data types. Okay, for example, I want to access this variable, so I will put dot. And then I can access this, and then I will assign this. So declaring this employee1 by this user defined data type that we have just created, we can have access to 4 variables which are stored, and we'll just put dot and then we can access these. Okay, so this is a record. For example, you want to build a record of type type book. Book is a name of a record. Okay, and then I'll just say declare name as string, declare price as double or float, let's say float, as float. Okay, and then end type. So now I've created a record of book, and inside this user defined data type it contains 2 variables which have different which are declared having different declaration. This is a name having a data type of string, this one is price having data type of float. And then I'll just declare book1 b1 as book, and now I can access through by putting a dot, and I will have name, C language, b1 dot price, which is $54, like that. Okay, after declaring it, after declaring it through user defined data type, now I can have access to these. So b1 dot name is equal to C language, b1 dot price is equal to $54. Okay, so this is record. For example, I have write down in pseudocode, in Visual Basic, and you can see this structure book. This is the name of a record, and structure book and structure have 3 things: price, title, issued. This is integer, this is string, this is boolean. Okay, now after creating this my user defined data type, now I can declare it the variables dim b1 as book. I can also have an array of this. Okay, b2, this is an array of 100 elements. Dim b2 as book, dim b2 index number 2 dot price physical 55 b1 dot price. Okay, and I can also give an output as well, b1 dot price, and then it will give an output as it has been shown in here. Okay, b1 dot price, the price of the book is 33. We just did b1 dot price is 33. Okay, so yeah, this is record. This is very useful technique which I have also used it myself. It's one of my favorite concepts. So we have done with user defined data types. Okay, now let's move on ahead to file organization and access. So there are 3 types of file organization. Number 1 is serial, number 2 is sequential, and number 3 is random. Serials means that you have a record of data which are stored in a file, one of the another, in the order they were added to the file, which means first in first. Like for example, you just keep on adding it, but they are not in order. They are not in order form. Okay, you just keep on adding it one after the another. So that's serial. It just keep on adding up, adding, but no, not in organized manner, not in sequential form, you can say. Okay, so that's serial. That in the order they were added to the file. Okay, they are added one after the another, one after another, and another and another in the order they were added. In the order they were added, but they will not be organized. So that's serial. Sequential is different. It's you just after adding them up, you just try to organize them as well. So they are stored in a file one after another in a given order. So they are stored in a given order, they are ordered. Okay, the order usually based on the key field of the record, as this is a unique identifier. And we all know what is the meaning of a record. Record means having like for example, a customer record contains the name, the age, the religion. So this is a record, and the ID would be is 001. Okay, so you are using the ID in order to arrange them in a suitable order. Okay, you are giving them the order by using the unique key field. So this is a key field based on the key field of the records. Okay, so that's sequential for you. Number three is random. Random means that you are adding something in a file, but in a random order, which means they are not organized. And the way they are added up to the file is by using hashing function. Now, what is hashing? We will come to that later. But just to let you know that they are added up in a file, but not in order way. Okay, they are adding up by using a hashing function, which just hash a value, and that value becomes the index of that particular record. It becomes the index. Okay, okay. So physically stored in a file in any available position by using hashing generated hash value. The location of any record in a file found by using hashing algorithm on the key field of a record. So we are actually calculating the key field of a record. Okay, it's by using hashing algorithm. We'll come to this later, that what is hashing, or maybe I could just show you. Hashing is, we use uh, this formula, that we are finding the value of k by we are calculating the index. Okay, by using k mod m. So k is a value, mod is m is the number of space available in the total length of an array. Total length of an array, or you can say of an array or a file, that you know. So yeah, so we use this to calculate the value. Okay, so this is our index, the index of the key field. I have just write down in here hashing algorithm. So hashing algorithm is used to perform a calculation on the key field of the record, gives the address where the record should be found. So using hashing algorithm, we are inserting in a file, and using this same hashing algorithm we can retrieve it as well from the file. So retrieve or insert, we can do that using hashing algorithm. Okay, by using this formula, k is a key value, any value, and the size of the hash table. It could be an array, it could be a file. Okay, so this is the formula that we will going to use. So this is the value, and hashing algorithm are used in the encryption of the data. We try to encrypt something, encryption, decryption. This encryption type is encryption has been used in banks and in somewhere where data is so valuable. Okay, so it has also been used in for valuable data encryption. And if for example if collision happens at some point, if for example you have the values, I mean you are generating a value but somehow you have the same index calculated, so there is a collision. How to solve this collision? In order to solve this collision, we have two methods. One is open hashing, which means separate chaining, and separate chaining consists of array and linked list. We will discuss this later in P4, but for now, just to have a brief description, brief idea what it is, about what it really is. It is the record is stored in a next free space on the next available space. Okay, as this is open hash, where the record is stored in the next free space. In the closed hash, we try to, okay, in the closed hash, for example, in the open hash we try to just store in the next free space the available next free space. Okay, in the closed hash what we do is, for example, you have this array, and this array is a hash table, and you have only one space left, the other is filled up. So before filling this up, we will have some kind of an algorithm will give which will give an idea that which will give a flag that yes, you need to uh, create extra space in here, like having extra two more, and then these two more you can call it overflow area. Okay, so overflow area is set up and the record is stored in the next free space in the overflow area. So this would be the overflow area which have been calculated automatically after knowing that we have only few space available. So before that space run out, flag becomes true, and then automatically more space are generated. So these are overflow area. So this is close hashing, we can call it rehashing. Okay, so this is hashing algorithm which are used only in random, and can also be used in sequential for retrieving the record. Okay, so we discuss about the file organization, serial, sequential, and random. Now in the file access we have also the three main we have two main the ways of accessing it: sequential access and direct access. In a sequential access, we can use it for serial file and sequential file. It searches for record one after another from the physical start of the file until the required record is found. You can just, for example, you have a file and you just keep on looking and looking and looking until you got the record. Okay, so that's sequential. You're doing sequentially, you are just finding it sequentially one after another. Okay, it's very simple. As for direct access, we use hashing algorithm to retrieve it, to retrieve the record. For sequential file, an index of all the key field is kept and used to look the for a sequential file and index. Okay, if the file is sequential, we will just going to remember that what is the maximum index from 0 to max index, and then we will just take it directly because we know where it is, right? We will try to have direct access through the given known index. You just know the index and then you just take out directly in sequential file only. So for a sequential file, an index of all the key field is kept, known, and used to look the address of the file location where a given record is stored. Okay, in the random access, for example, if you have random access file, you will use hashing algorithm to retrieve that key field, to retrieve that record by calculating the address of the file location where a given record is stored, use on the key field. Okay, so this is file organization, this is file direct access, and now let's move on to floating points. Normalized floating point representation, and by means of floating point I mean like 5.7624. This is floating point, so we are converting into binary. So how to do that? we're going to use this beautiful table right in front of you, boys and girls. Fixed point representation in binary. Fixed point representation in binary format. So we all know this. These digit 2 power 0 will be 1, 2, 4, 8, 16, 34, 64, 128. But before 1, we will get decimals. We will get decimal points. And how to represent them in binary? We will we can represent them in binary in this way. Okay, so 2 of power minus 1 will represent 0.5, 2 of power minus 2 will represent 0.25, 2 of power minus 3 will be 0.125, then 0.0625, 0.03125, in this manner. All right, now conversion from denary to binary. So now we're going to convert the floating point into binary. So for example, let's suppose we have 1.625. Now we need to convert this into binary. How to do that? We're going to use the same table that I just showed you guys. So we'll write down in here, and now you can see here, so 1, so we'll just put 1 in here, then 0.625, this is 0.5, this is, this is 0.5, this is 0.25, and this would be 0.125. Okay, so 1 to 5, right? So it could be, yeah, then we have 1, then we got 0.125, and now we need 0.5, so we'll put 1 in here. So now we have our binary representation 0.50, which means this would be 1.625. Okay, and same exactly which I just done right in front of you. So we got the binary representation. And okay, another thing here is we need to check about the sign. So right here in front of you, this is positive. If it is positive, then we will put 0 at the leftmost side, which we can call it a sign bit. If it is negative, then we will put 1 on the leftmost side. So right now we will put 0 because it is positive. So 1.101, and then we just put 0 because it is positive. Supposing we have another number, decimal points in decimal form, and we need to convert it into binary. So again we'll use a table. We can say that 40. Okay, so we'll put 1 in here and 1 in here. This would become 40. Now let's see, 1.25, so this is 1.25, and then we'll just put 0 on the onto the rest. So this is a binary representation. And yeah, so there you go, we have 101 101 001 001, and don't forget to put dot in here, just to let you know, just to make sure to understand that yeah, these are decimal points. Okay, same thing, I put dot in here as well. So you need to make sure that you put a dot, not to get confused. Okay, you need to put dot. So 101 101, and then you put a sign bit, which is 0. Okay, so you understand about how to convert this. We just try to convert this by using a table which we make ourselves. Now what we're going to do, we need to understand about normalization, about mantis and exponent. So let's come to here. This is mantissa, this is exponent, and whenever we have in this format, we can just say that yes, it is in normalization form. It is in normalized form, you can say, if we try to write it down in this manner. Okay, we need to find, when we try to put in normalized form, we will have in this way. For example, 4012.5, we just put in normalized form. How to do that in binary? Let's see how. So now we have this, and now we need to convert this in normalized form. And in order to do that, what we're going to do, we're going to put this dot into the leftmost side, and in here, okay, in the leftmost side where it is next to 1, and next to the sign bit. Okay, so 1 2 3 4 5 6, so we have at least 10 of power 6, and now we're going to convert this, right? So 6 would be in binary, it would be 1248, which means it would be 1 and 1 0 0. This would be in binary format. So this is our exponent, and we're going to convert this in the mantissa, and we'll just write down in this format. So this is a sign bit. Okay, the normalize it by putting a dot on the extreme left. We just did that, and we have put it the dot in here. We got the exponent, and there you go. This is the mantissa, and this is the exponent. This is the normalized form. This is the normalized form. Okay, so why do we do normalization? Reason to normalize: in order to have high degree of accuracy as possible. Yes, accuracy as possible. That's why we try to normalize it, right? In order to make it more accurate, in order to read it more accurately. So that's why we try to normalize it, even in binary format as well. It's really important. Okay, so we have done in positive floating numbers. What happens if we get negative ones? So let's see. Let's suppose 0 1 minus 2.5, and now we need to convert this in binary format. Okay, so there are two methods. One method is first method is someone I use it myself. It's very easy. The second one is the two's complement method that is written in the book, which I don't want to use it myself because it's very complicated, but it could come in a paper, so I'll definitely going to teach you that. But just to make sure, just to know that for example, if you want to compare, if you want to just want to know that the answer is correct or not, you can just do my method, the first method. You can just use it and then find the correct answer, and then just for the sake of the paper, you can do in two's complement form to show these guys that yes, you know the knowledge of how to do two's complement form, and then you just give the same answer. Okay, so first I'll show you my method. My method is I'll just put negative on the leftmost side. Okay, like for example, if I want to calculate 2.5, so what is greater than 2 in, it 1 2 4, so 4 is the least, I mean it's on the left, most left, it is greater than 2.5, so minus 4, and I'll just do minus 4, and then I'll just do 2. Okay, this would be the other, all of them would be in positive form. So minus 4 plus 2, this would be, or maybe not 2, I'll just say 1. So minus 4 plus 1 would be 3, and then I'm going to, okay, this is minus 3. Minus 3 plus 0.5 would be 2.5. So there you go. This is how it will come. It would be 1 in here. I will put 1 in here, then 0, and then 1, and yeah, and then in here it would be 1. Okay, so 1 0 1 1, and this is also the sign bit. So 1 0 1 1 1.101 point 1, you need to put point as well, remember that. Now you need to, now you need to normalize it, and you just put in 1 2, so the exponent would be 10 of power 2. So this would be converted in binary, and this is a negative sign, and then you just and yeah, this is normalized form. Okay, this was my method. Now the second method is doing in two's complement form. So first of all, you'll just try to assume that this is in positive form. I need to convert this into binary, so you'll just do it as I've done before so many times. So 101, okay, fine, you got 2 and 0.5, so 2.5 you just convert to binary, and now you're going to do two's complement form, and that's why we use it 2 complement form for any negative values. Okay, so we just flip 0 to 1, 0 1 0 to 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. Now we add 1, and there you go, this is two's complement form. And now we need to normalize it, and thus point will come on the left, 1 2 2 2 of power 2, 10 of power 2, and we just convert this, and there you go, this is normalized formed 1.00 1.1.011 010. This is normalized form. Okay, now we understood about how to deal with this normalization, and we understood about why do we normalize it. Now we to have some more, we to go into more details. Okay, let's start from here. What would be the largest number? The largest number in positive form, right? So you can say in whenever we have integers, whenever we want to remember represent binary in integer format, we will have range. So the maximum positive number would be plus 128, and the most least would be minus 127. This is the most this is the largest number in integer. Okay, so all of them would be 1 except for this one, so it will be a total of 128. But also uh, we need to count those decimals, right? 0 0.5, 0 0.25, and all that. We can also count them as well. That will help us to increase the number as well. So the exponent will be 10 of power 6. Okay, yeah. So this is the largest positive number. This will be large. So the dot will be shift to the left. I mean, if it will shift to the right, and you will have so many number of 1 and they all will be added up. It will become the largest number. Okay, that's why the exponent is very huge, 10 of power infinite. Okay, maximum. Now the smallest number is when you put 1 and the dot will go to the left. If the dot will go to the left, it means it is in decimal point. It could be the one representing it might be 0.00001, something like that. So the exponent taking the dot to the left, the exponent is taking the dot to the right, which makes it more makes it the largest number, because dot is going to the right. So having 1 dot is going to the left, so 1.00000, like that. Okay, now having the smallest negative number. So having the smallest negative number, like for example, if we have minus 1, then this would be the largest number, negative number. And if we have minus 99, so we will have the lowest, smallest negative number. This would be the largest, this would be the smallest, like this. So we just put 1 in here, which means this would be minus 127, the smallest negative number. Okay, and if if exponent, I mean the power, the 10 of power, it is in infinite form, so it taking you to the right, so which means dot is going to the 0, which means it would be minus 127, the smallest number. And what happens if we want to calculate the largest negative number? So we will just going to take this, we just do 2's complement, it will be converted in this form. Okay, so this would the smallest positive number will become the largest negative number. It's mathematical logic. Okay, so 0 becomes 1, 1 becomes 0, the rest will be flip, like that. So this is how you can remember it if they ask you about anything like that. Now moving on to overflow. Okay, supposing that, okay, if a positive number add to the largest positive number, then okay, if we have the maximum number, like for example 127 is the maximum positive number, and we try to add one more thing, then it becomes overflow. It won't be countable, it will become overflow. It can be represented anymore further. That's overflow means. Overflow and underflow. If a positive number added to the largest number, that the number becomes too large to represent in binary, which will result in overflow. And underflow is the same thing and vice versa. If it is most lowest number and you subtract one more negative number, then it will become underflow. Okay, then we have changing the allocation of bits to mantis and exponent. You are just balancing it, and there's a trade-off that you need to think about. You need to understand what would be the benefit of increasing the mantissa or decreasing the exponent. You need to make sure to understand the trade-off depending on your requirements. Okay, so increasing the mantissa means increasing the range, increasing the exponent means increasing the precision. So more bit used for exponent will result in a larger number of, okay. So range is used for exponent and precision is used for mantissa. So trade-off between range and precision. So more bit used for exponent will result in a larger range of numbers. Having some, obviously, if you're putting a 10 of power infinite, and you will have so many ones, right? You are increasing the range, so that's why it represent range. As for the precision, more bits used for mantissa will result in better precision. Okay, yeah, in better precisions, yeah, in representing more of these tables, mantissa representing, you would be able to represent more of these. Okay, so more bit used for mantissa will result in better precision. That's a trade-off. Then we have boundary representation can give to rounding. Okay, there is a problem in the, if for example, if you are doing a calculation, in you're doing a code, you are doing coding, and you are doing any mathematical calculations, and you want to round it off, you want to know the extreme accurate number, but there are the chance of rounding errors as well. It could give rise to rounding errors. For example, you're adding 0.1, this will not be rounded completely, so these are errors, rounding errors. Why this so? Because you don't have enough representation of the bind of those decimal points. Like if you increase the precision, the mantissa, then you can have more decimal point to represent, like 0.5, 0.25, and it will keep on decreasing. Even for the smallest number we can represent in binary form. So increasing the mantissa will help us to make a better precision. So error could be reduced by increasing the size of the mantissa. So right in here, this is the size of the mantissa: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bits. Increasing the number of bits will help us to increasing the number that we can represent in binary for the decimal points. Okay, and this will help reduce the error. Okay, so we have gone through all of this, and okay, so now we have come to converting from binary to denary. Even though we have done from denary to binary, you can say floating points to binary format. Now we're going to do in binary into floating points. So right in front of you we have the mantissa, and we got, this is the mantissa. Okay, this is the exponent, and this is the sign bit. In the mantissa we have these numbers. So before converting from binary to denary, first of all we're going to denormalize it because it is a normalized format. So right now the exponent is 10 of power 4, it's 10 of power 4, and we got this. We need to just, which means we need to go right, we need to put the dot, which means the dot is in here. This is the dot. It will come 1, 2, 3, 4. It will come here. Dot will come here. After converting it, now we're going to add them up. So 1 upon 2, 1 upon 8, 1 upon 16. Oh, sorry. After putting the dot in here, which means after putting the dot in here, now we're going to see what is the value. So we got the exponent, we got the mantissa, we just put 1, 2, 3, 4, 1, 2, 3, 4. So yeah, now we're going to see what is the value. Okay, yeah, same thing. Now this is 1, this is 2, this is 4, this is 8, and this is 16. This one is 0.5 and 0.25, which means that the value is 8 plus 2 plus 1 plus 0.25, and this is the value 11.25. Same thing as happened here. This is method 1. which I've done it myself. This is a method I always use. It's the most favorite of mine. The second method is when you try to use a formula. First, you're going to just before doing all of this, like before putting the before doing the exponent, going to the right stuff. No, we're not going to do that in method 2. We're just going to add them up, like 1 upon 2 plus 1 upon 8, add them up. 4 upon 64 is the mantissa. The exponent is 4. Okay, now we're going to use this formula, m multiplied to the power e. This is the formula to directly calculate it. We just put it and then we're going to find the values easily. But I will prefer this method because it's very easy in my opinion. But if you think that this one is easy, then you can just add all of the values and add the exponent and just do the calculation and you got the values. So this was it. That's it. This was chapter 1. Alright, this was chapter 1, complete chapter 1. The floating point representation is done, and file organization access is done, and user defined data type is done. Chapter 1 is complete. And now in the next video we will go to communication and internet technologies. Okay, thank you so much. Goodbye.